Hello friends, in this lecture we will cover the next type of sensors, that is mechanical sensors. Now the learning outcomes. Now after studying this topic, student will be able to understand first what is strain gauge, then what is load cell, and third what is pressure sensors. Means in this lecture we will cover total number of three mechanical sensors, that is strain gauge sensor, then the load cell and the pressure sensors. Now what is strain gauge? Now strain is the amount of deformation due to an applied force, and more specifically strain is defined as the fractional change in the length when the force is applied. And strain can be negative, that is compressive, or it can be positive, that is tensile, whereas the dimensionless strain is sometimes expressed in the units such as inch per inch or millimeter per millimeter. Or the strain gauge and also a strain gauge is a passive type of sensor, and it is also a resistive transducer which converts the mechanical elongation and compression into the proportional resistance change, and this change in resistance takes place due to the variation in the length and the cross sectional area of the gauge wire when the external force is applied on it, and the variation in the resistance is converted into the variation in voltage by connecting the strain gauge in a Wheatstone bridge. Now the strain gauge are basically divided into or classified into two types, that is wire gauges and second one is the semiconductor gauges. And wire gauges are again classified into three categories, that is unbonded wire gauge, then the bonded wire gauge and the foil type wire gauge. Now let's see the working of the strain gauge. As I told, the variation in the resistance is converted into the variation of voltage by connecting the strain gauge in the Wheatstone bridge. Now here the strain gauge is connected in the Wheatstone bridge circuit, and the change in resistance is proportional to the applied strain is measured with the Wheatstone bridge. Now here in this Wheatstone bridge the strain gauge is applied uh, to this bridge. Now here when we apply, now when we are not going to apply any force to the strain gauge, now for that condition our Wheatstone bridge will be in balance condition. Now when we will apply some force to the strain gauge, then our bridge will be in unbalanced condition, and at the node, that is A and B, we will get some voltage. This is how to convert our resistance into the variation of voltage by connecting the strain gauge into Wheatstone bridge. Now one important term in strain gauge sensors, that is the gauge factor. Now what is gauge factor? The sensitivity of the strain gauge is described in terms of the characteristics called as a gauge factor, and gauge factor is defined as the unit change in the resistance per unit change in the length, and it is basically gauge factor is denoted by capital K, which is equals to del R by R. Now upon del L upon L. Now where the R is the resistance of the gauge wire, which is in ohm. Similarly del R is the change in resistance of wire, which is in ohm. Similarly, what is L? L is nothing but the length of gauge wire in unstressed condition, which is in meter, and del L is nothing but the change in length of wire when stressed or when the pressure is or when the force is applied, and unit for del L is again in meter. This is how to calculate the gauge factor of any strain gauge. Now let's see the first type of strain gauge, that is bonded strain gauge. Now in bonded strain gauge, the bonded resistance wire strain gauge, the resistive element is cemented to the base, which may be a thin sheet of paper or thin sheet of bakelite or sheet of Teflon, and the resistive element may be in the form of the wire or foil or the film of the material. And there are basically three types of bonded strain gauges. First one is the fine wire strain gauge, then second one is the metal foil strain gauge, and third one is the semiconductor strain gauge, and the working principle for all the types of, or for all the three types of bonded strain gauge is same. Now here one picture it shows, this is just for example. Now in this picture the wire grid is used. Now when we apply some force or pressure to the wire grid, then accordingly its length will change. Now when the length of this wire grid will change, accordingly its resistance will also change, and the same principle is applied for all the three types of the bonded resistance or bonded strain gauge, that is fine wire strain gauge, or metal foil strain gauge, or semiconductor strain gauge. Now let's see the next type of strain gauge, that is unbonded strain gauge. Now the unbonded strain gauge consists of a wire stretched between the 2 points in an insulating medium such as air, and one end of wire is fixed and the other end is attached to the movable element. And the picture shows the structure of the unbonded strain gauge. Now it consists of two frames, that is P and Q, carrying rigidly fixed insulating pins, and these two frames can move relative with respect to each other, and they are held together by spring loaded mechanism. And a wire is stretched between 2 points in an insulating medium such as air, and a wire is kept under the tension so that there is no sag and no free vibration. Now when the force is applied on the frames, then the frame P moves relative to the frame Q, and this produces the stress and strain, and this strain changes the resistance of the strain gauge as it changes the length cross section of the wire, and the change in the resistance of the strain gauge is measured using the Wheatstone bridge, and when we calibrate, then it becomes the measure of the applied force. Now this is the principle for the unbonded. And the third type of strain gauge is the foil type of strain gauge. The foil type of strain gauge has the metal foil photo etched in a grid pattern on an electric insulator of the thin resin, and the gauge leads are attached. Now picture shows the foil type of strain gauge. Now let's see the next type of mechanical sensor, that is load cell. Now here the picture shows the load cell. Now a load cell is used for the weighing extremely heavy loads, and the load cell uses the strain gauges for measuring the weight, and the weight is applied along the direction shown in the picture, and due to this stress the steel bar gets compressed along the axis S and expand along the XY axis, and due to this the resistance of the strain gauge A will decrease and that of the strain gauge B will increase, and this increase in this increase the its sensitivity 4 times as compared to the single gauge, and this arrangement will make the load cell very sensitive to a very small values of the applied stress. Now this is the working principle of the load cell. Now let's see the last type of mechanical sensor, that is pressure sensor. Now the pressure sensor, again it is a type of mechanical sensor which is made up of elastic elements such as the diaphragms or bellows or the Bourdon tube. And there are some advantages of pressure sensors, like it is used to measure the absolute and differential pressure. Then it is used to measure the low or medium pressure range. And there are some disadvantages of pressure sensors, like it is not useful to measure the high value pressure, then bellows joint can fail, and no in place maintenance or repair can be performed. They must be replaced if they are damaged. This is all about the pressure sensors. Thank you.